Hello, everyone. Okay, hello, everyone. Okay, just to help with this one is apply for student and tech 2. Look like everyone's still having problem of doing your C++ programming for your first D lab Okay, so I'm going to go through it pretty quickly just to show you an example. Okay, so make sure you pay attention. This is for Tech 2 student. So for student who's in Tech 1, if you want to take notes, and potentially you will be doing this next semester if you come back and join us. So make sure you can take notes too. So, okay, so I'm going to go to share my screen. Okay, so share my screen, share. Okay, so this is my share screen. All right, so first thing you want to do is, okay, so I'm going to be setting up I'm going to set up my folder here for, so I'm going to put everything that I'm going to do here into my temporary folder for this demonstration, okay? So I already create my own folder. Like I said, you can click on new folder to create that. So I'm going to use that as my demo. All right. So now I'm going to just follow the website. So here is the website. Okay. So first thing you want to do is download the assignment number 1 and make sure you go through and make sure you complete it. Don't go and continue on the other assignment. Make sure the number 1 is working and it's make sure it's working correctly. So this is my number. So this assignment, let me see. So this assignment number 1. Okay, so the assignment number 1. So you have to go through this assignment. Make sure you have to follow this instruction. You have to complete number 1, step 2, step 3, step 4, step 5. I see a lot of students have done up to step 5 and they uploaded the website, but they never did. They did not do this step here, which is said write test program to test the circuit. Now I already built up the circuit, so you just have to do it. Just make sure you're writing the code to test your program. Okay, so once you have that done and this one is passed, okay, so I'm going to go ahead and use my pass one, the one I did it here already. So tech 1, tech 2. This one is Excel, and this DLab number 1. So number 1 was fixed. Okay, as you can see, I did this one and did the to do PSpice. I need to collect all these data. And then with that, I'm able to complete this here. And then after that, I transfer the data that was on this truth table here. This is from port A information, A1, A2, A3, A4 to my port here. So this is going to become to A1, A2, A3, A4. So I do it just come in here, copy this information here. So Control C, and then go into here and paste it here. Okay, so that is it. And then after that, you want to define what the hex data for this value here, 0, 0, so 0, 0. And this one is 0, 0, 0, 1 is 0, 0, 1. And this one you have to do, this one you have to fill out. And then you same thing with PC2. So take whatever here in PC here, copy it, go to the next go to this page and just paste it. Okay. And the mass data is depending, is what circuit what pin are you using. Okay. So this is an 8-pin output. So therefore you want to turn this one on, you want to turn this one on, and you want to mask out the other pin because you don't want any data from it. So 0, 0, 0, 0, 0. So therefore the mask data is 0x. Okay, the first 4-bit on this side is all 0. So therefore 0x, which is represented hex. And now you enter the value 0 because it's on a 0 from PC5, PC6, PC7, PC8. And on the other side is going to be 0, 0, 1, 1, which is going to be 0, it's going to be 3. Okay, so that is how do you determine your hex data, the mask data. It's what pin did you turn on, and it's based on this 4-set system. Okay, so 4, 4. Okay, so this is the upper bit, this is in the lower bit. So this is so 0, and then x 0, 3, that is your hex data. And now you have to do it just now. I can type in all the numbers 0, 0 here, but I just look at this one here. This one is going to be just a 1. This one's just a 1, 1, 0, 0. So, and this is 1, and this is a 2. So 2 and 1 would make it 3. This is 2, and this is 1, 2 and 1, make it 3, 0, 0. And that's how you fill up this table. Okay, once you have completed this table, next thing you want to do is go to the website. Okay, website, you want to do is go into your handout here. You want to scroll down to, so this one is your digital program, digital. And here is a sample program Mr. Pham already developed for you. So copy that in nothing else. So Control A, Control C. No, wait a minute. You don't need that. Okay, so next thing you want to do is follow the okay, so next thing you want to do is go to the handout. So you want to do is follow the instruction how to set up your Visual Studio. Okay, so now click on my Visual Studio setup. It's already, this is instruction. Okay, the instruction here to set up your Visual Studio. So therefore you want to do, click open that up and follow the instruction. So it said open Visual Studio 2015. This is my Visual Studio 2015. So double click that to open it up. Okay, so I'm going to use that as my, okay, so now I have my Visual Studio. Let's see, where is my Visual Studio? Okay, so let me see. All right, Visual Studio right here. Okay, so this one open. Okay, so next thing in this one that in the new project. Okay, so now we look at the projects that you'll be working on is on your Excel. Okay, so this is on your Excel. Okay, so this is Excel. So this is your assignment. So this is the name of your project. So you want to do is, well, they don't want me to do that. So I'm going to say, I'm going to copy this one over, copy, and then just use any sheet for now. Okay, somewhere over here, paste it. Okay, now I can come in here and copy the name of this project, which is DLab01. Copy, come in here and follow that instruction. So new project. Okay, new project. Okay, step 3, go Visual Studio, Visual C++, Windows 32 console. So here's Visual. Here's Windows 32 console. Okay, that's done. Step 3 is done. Step 4, go to the name window, which is down here, and type in your name of your lab. Example, DLab01 Spring. Okay, so we're in the fall now. So Control paste the one that I just copied from the website. Okay, from my Excel. Okay, and you put it here, and then now you want to do, okay, so that is done there. So now next thing you want to click on browse and locate where your project you want to save it at. So right here, location, click on browse and go through here. I want to save, either I can save on my C drive or my D drive, but since I set it on my D here, I just choose my D drive here, and this is the folder that I'm going to put it in. Okay, so I'm clicking on there. I'm going to use that folder and click OK. Okay, so that's done. Okay, next thing is that to click on OK. So OK. Now that's done. Now we're in step 6. Okay, so now we have to do is in the window. So this is Window Application Wizard. So this is that Windows 32 Application Wizard up here, and click on Next. Okay, so here, okay, so now step 7 is that put the check mark an empty project and then check security development. Okay, so right here, you can go here. You can uncheck all 3, or you can uncheck just the security, and you want to put a check mark on empty project. And once that's done, click on finish. Okay, finish. Okay, so that is finished. So that's done. Now we're on step 8. So say right click on your project and scroll down to properties. So your project is the one highlighted in bold type, or the one that said C++ right here. So right click on it, go down to properties, which is the last thing on the list. And then you come in here and then make sure that it's going configuration property, here configuration property. And then you want to do is go to find the one that's a common language run support. Okay, so which is this one right here. Okay, so next thing, step 10, click the down arrow to select common language run support. This one here. So the arrow is be right here. So you click on that. So you want to choose the second one here. And once you have that, click OK right here, step 11. Okay, so step 11, we're done. Okay, step 12. Okay, so we're going to have to right click on your project again, go down to add a new item. So we're going to go here again, and then go to add new item. Okay, you come in here and just paste the name of your program, your assignment. Okay, and you paste it there with the extension .cpp. Okay, so that's oops, CPP. Just like this one here, right here, number 14, they said right here, example. Okay, type in the name of the lab, then click on add. Okay, so now we have done, click on add. Okay, now your now says C++ template is now ready for you to write your first test program. Okay, now that you have that done, now you want to do is go back to the website, go back to the handout, scroll down to digital. Here's a sample program. Click on that to open it up. Control A to copy that. Okay, and then you come in here and here. You control paste. Okay, now you have that sample of that program. Now you can go ahead and delete half of these tests, and you don't need all these tests. You need just the first test. Okay, so you want to keep all the other part, but just get rid of the test 3, 4, test 2, 3, 4. Get rid of it, and just keep all these end part. You need this part, and you need this part. Okay, so now I have to do is just put some space here in between, so I know test number 1. Okay, so now I have to do is just go back into the my Excel. Okay, my Excel, and look at the like I said. So copy the name of your assignment. Come in here, put in the name of your assignment. So here's 1. Here's 2. Here's 3. Here's 4. So there's 4 places that you have to change to put in the name of your assignment. Okay, so 1, 2, 3, 4. And then after that, the programmer. Who's the programmer? You are the programmer. So you want to make sure you put your name in there. Okay. And then version date. Okay, what is today's date? Today is November 11th. So therefore, come in here, change it to November 11th. November 2nd. Sorry, I'm ahead of myself. Okay, so now I have the date there. So I copy the date here, copy. Wherever the date is at, I'm going to put that one in. So here's say October 22nd. So I'm going to change that to November. Okay, so that is pretty much it. That's the only 2 places where I see the change that need to be changed. Okay, so my name. Okay, this is here, the include file. And you want to do is come in here, and then we're going to be putting, look like some information here is missing. Okay. Okay, so now I have to do is, okay, so semester. So this is semester for this semester for this semester, and it's going to be for Tech 2. If you're in Tech 1, you change it to Tech 1. Tech 2, you're in Tech 2. Okay, so this is assignment is for Tech 2. So therefore, it must be Tech 2. Last name, my name. First name, Sam. Okay, now that I have that done, now I have to do is just come back in here and put in this information onto, okay, getting the information from Excel into your program. Okay, so first thing you want to do is test title, test number. So this test number is number one. So therefore test number one is be number one. And test the title of it is going to be test one. So therefore you can type that in, test one, test 01. Okay. And then what is expected data? This expected data is come from port C, which is right here. So this is the first test. It's going to be 01. This is so this is from port C. Okay, info from port C. Okay, so and this one is also mass data. It's mass data is right here. Transfer that. Make sure that it matches to the one that is in the info from port C. Okay, so now I have that information. And there's PCOF, possible cause of failure. Okay, when you run it, what will what's going to cause it to fail? Okay, in this case, we're going to use U1, U2, U3, U4, which is to be put right here. You change it accordingly to whatever your lab is. So info from port C. Okay. And then, okay, now my input. Okay, so this one input is saying from port D. Well, in this program, the input is only from port A. So therefore, I'm going to write port A. And what is my input for port A? So my port A is going to be 0x00. So 0x00. Okay. And this is info input from port A. Okay, so input from port A. And that's it. And that's pretty much it. So once that have done, then and then now we have to do just make sure you build it to make sure that it's working correctly. Or there's no error before we start doing more programming.
Question for you, Sam.
Yes.
It's case sensitive when you type the port A and things like that?
Yes, it is case sensitive because the way that we define this, everything inside coding, it's always going to be case sensitive.
Okay, thank you.
Yes, you're welcome. Except the one in the comment. The one in comment is not case sensitive.
Right. Yeah, I understand that one. Thank you.
Yes, you're welcome. Okay.
The program though itself is.
Yes. Okay. Now that we have that is done, now we have to do is just copy this first test and go down to a few lines and paste. And then, so this is going to change it to number 2 and then change it to test 2. Okay, test 2. What is your expected from test 2? So test 2 is right here. Expected will be still 01. And the mass data didn't get changed. So therefore, I don't need this one here. So you can leave it there. That's fine. You can still use it. If not, it's not changing. So you don't have to keep this here. Okay, peak-off only show up one time. So therefore, we don't need that. We don't need to do another peak-off. Okay. All right. So therefore, now we have to do is, okay, so this is test 2. What is the input? Input is from port A for test 2. So test 2 right here, pin 7, it's going to be 01. So I changed this one to 01. And that's pretty much it. Then after that, just do the same thing. Now we have to do just copy test 2, go down to the next line, paste it, change to test 3, and change the name of the test, and so on and so on. So test 3, the expected is going to be still 01, and the input for test 3 is going to be 02. So 02. Okay, so as simple as that. So any question for Tech 2 student?
Nope.
Okay, so yeah, just make sure that you follow this example. So that way, Mr. Pham already put a sample program on the website. Use that sample program. Don't try to use anything else. Some of the students try to upload some other one that, when I run the test, it's failing like crazy. And I know why. I can read it when I read it. You didn't use the sample program that Mr. Pham gave you on the website. Use that as your template to writing this coding. Okay. Don't try to create something your own until you become a proficient at it. Then you start changing things. But right now, use the sample. Okay. Thank you. So anybody have any other question in Tech 1 or anything?
Thank you, Sam.
You're welcome. Okay, and then once you have completed this, okay, once you have this completed, and then you want to do is Control A, copy. You want to do just Control A here to highlight the whole thing. Control C to copy, and then you want to do is just go into this. You come in here, say somewhere in one of the sheet here somewhere, and so the sheet here. So Control Paste. So Control Paste. There it is. Now I have my program. So this one here, I'm going to call it C++ here. Okay. So and then now I can save this into this file. So make sure I save it. Okay. So let me go ahead and exit. Let me see. Share back to share.
Hey, Sam.
So, hold on one second. Okay,
No worries.
so all right, so make sure that you save this file, and then after that, you want to go into the website and upload this Excel, because I want to make sure that I'll be able to see everything on the Excel. I want to see this information. I want to see this information. I want to see this information. I want to see this C++ program in there, and then I'm going to use this information to put onto Excel, and then I'm going to be put it on the Visual Studio. And then I'm going to hook it up onto this board, which is a DLab 1. And I'm going to test that software that you just uploaded with your Excel. And that's uploaded to the website, okay? And once, so like I said, this one, once this one is safe, and so now I can go say, minimize that out the way, go to the website, and then go back into, go in here, and then go into upload, go to upload file, go in here, type in my name, Sam, last name. Okay, so this is for Tech 2, so it must be going to section 2 assignment. So therefore you want to do is click on this one here, and then choose your file. My file was ET, so it's going to be here, Tech 2. It's going to be, it's on Excel. I just saved it. And it's going to be in my DLab number 1. Oops, this one is in Tech 2. Tech 2, Excel, DLab number 1, which is this one right here. Click open, and it shows up here, and I click on upload. Okay, so now it's in my file to find out to see if it's there, to just confirm. Okay, so you always want to make sure it's there. So now I checked it. Okay, so there it is. Okay, so now the instructor knows when they go through and they open up this, they can see it's there. Okay. All right, so that's pretty much it. Okay, any question?
Yo, Sam, this is Alistair.
Okay.
Hey,
Yeah, Alistair.
what kind of, so do we have to delete all of this kind of instructional stuff that's included in the example code?
You just saw what I did, right? You follow exactly what I just did.
Okay, yeah.
Can you follow that?
Yeah,
So
I jumped in halfway.
Oh,
but
okay.
You can delete like change name and all that stuff, right?
Yeah, just follow the simple structure for now. Okay. When later on, once you have more chance to work with it, and then you want become more familiar with it, then you can start changing later on to whatever the preference that you prefer. Okay. But this one you want to do go by this one, because that's how this control box will be responding, is according to the way that Mr. Pham sample program. Okay.
Got it.
All right. Thank you.
Cool.
Okay.
But
I
also,
have a question, Sam.
Yes, Viola.
Mine, I uploaded everything individually,
Mhm.
through the notepad. Do you want me to go rearrange them the way you just telling us right now? And
No,
resend
I
it
mean
again?
all the other one. When you do it, that's the way that I want you guys to do it. Make sure
Okay.
you do the Visual Studio. Make sure you compile. There's no error. Then copy that and paste it onto your Excel. Okay, and then just put a page down there and just label it, say C++. And so that way I know when I open up that Excel, I see that C++, then I can use that program to put on the Visual Studio, and then I can be able to run the testing on the board.
Okay, so for the one that I submitted, just let it go?
Yeah, just let it go. For that's already that's
All
already
right,
there.
thank you.
You're welcome. Okay, so I think what's Adam that was trying to ask me a question or no?
I was just going to point out that when talking about the sample program that Mr. Pham has on the website,
Yes.
a lot of the instructions on that are probably commented out, so you don't have to delete them per se. You can leave them up, and it's just for your own reference of.
Yeah, that's a good point. So yeah, you can use that. You can create a sample program that's to use, but like I said, that is a good sample program that Mr. Pham put up. So use that sample program. I know other student that try to use his other thing, use what they have before, and it's not running. It's failing. I run the test, it failed, and I said, don't use that. Just use the sample program that's on the website. Change a few lines that according to your Excel, and then put it into your Visual Studio. And once you have that done, copy and paste it there. Okay. So thank you very, very much. And we're back to Mr. Pham.
Thank you.
Thank you.
Thank you, Sam.
You're welcome. Okay, look like we got a few questions here.
Actually, we don't want any more people said.
Okay, back to you. Let me see.
Okay, last time we already talking about the active filter. Okay, want to continue it. Okay, so first thing we're talking about low pass filter. Okay, look at the low pass filter, high pass filter, band pass filter, and band stop filter. And we already know we get the passive low pass and active low pass. Active low pass is using the op amp, adding to resistor, capacitor, and resistor to make the filter. Okay, and this we will show you how the low pass filter working. So the low pass filter will be allow any signal from 0 up to cutoff frequency. Okay, that means any signal from the 0 frequency up to cutoff frequency to pad. And any frequency higher than that will be stopped. That is a low pass filter. Okay. And also they can give it to you the different type of the filter. The first one you can see right here, that means minus 20 dB per decade. That's only telling you when you try to increase 10 times of the cutoff frequency, they will be going down at 20 dB per decade. And that will be a one pole, okay, low pass filter. And the next one, you can get a minus 40 dB, two pole. And the last one here will be minus 60 dB per decade. That three pole. The ideal filter you want right here. After the cutoff, you don't want any frequency, any signal. Okay, so minus 60 dB will be the best in this example. Okay. And on this one, we already done or not? Okay, we get a low pass filter. They given you R will be 1K, C will be 0.1 microfarad. And this one they're using the unity gain amplifier to build a filter. So the gain will be equal to 1. Okay, so the answer we already did last time, I believe so. Gain equal 1. What the cutoff frequency?
7.07 volts.
Cutoff frequency
1.59.
1.59, right?
Yes, sir. Sorry.
Okay, VL at the cutoff will be, is it right?
7.07 volts.
Okay, and VL at the 10 time. That's what we already done last time. Okay, any question on this example? Okay. The next one here, example, they using what the name for the circuit. They using what? Inverting, non-inverting, follower.
Inverting.
Inverting. Or non-inverting.
Yes. Non-inverting.
Non-inverting. Okay. And the gain of the non-inverting will be 1 plus R2 over R1. So what AV equal? 10, right?
10, yes.
Yeah, last time I believe we already done. Cutoff frequency 1 over 2 pi FC RC
159.
159. What the VL maximum? You want VL maximum, you take the input times the gain. Is it right?
35.
Mr. Pham, Mr. Pham, can I stop you there a minute? Got a question.
Yeah.
R2, what's the value of R2?
R2. 9K,
Still
right?
high.
9K 1 ohm, or is it 9?
9K ohm. That's maybe the typo.
Okay, all right, thank you.
Okay, number 4. VLS cutoff.
$17.65.
Oh, what?
That scared me, bro. That scared me.
Is it a VLS cutoff? It will be 17.67. If you want to calculate the VL at the cutoff, you take the VL maximum times 0.707. And the last one will be 2.5. That means the VL at 10 FC. You want to calculate the VL at 10 FC, you take the VL maximum times 0.1.
Can you repeat the number 5 again, please?
Number 5.
Yes, please.
Okay, if you want to calculate the VL at the 10 time of the cutoff frequency, you take the VL maximum times 0.1.
Yeah, maximum times 0.1. Thank you.
Okay, the next will
Hey,
be
Mr. Pham, could you put that back real quick? I was writing something.
25.
Okay, thank you.
You're welcome. The next will be a high pass filter. Okay, so that's just the opposite to the low pass. They will be pass any signal higher than the cutoff frequency. Okay, so this is the cutoff frequency here. Any frequency signal higher than, they will be allowed to pass through it. Okay, less than cutoff frequency, they will be alternated. So that's why they say bandwidth of the high pass filter right here. They're telling you bandwidth or pass band. And the formula to calculate the cutoff frequency the same like low pass filter. Okay, now we want that to do calculation. Okay, so the gain. What is the gain for this filter? What the circuitry using for the high pass filter here? What amplifier?
Is that inverting?
For this circuitry here, what the amplifier be used to build the filter?
Inverted,
Inverting, correct?
using the negative.
Yeah, input connect to the negative. And the gain will be equal what?
1.
One.
Will be minus, right? R2 over 1 R1. Okay, so what is the gain equal?
.7?
2 minus 2.7. Is it correct? Yeah. Okay. Cutoff frequency. Did we do last time? Or no?
No.
No.
No, okay, do it now. Cut off will be equal 1 over 2 pi.
Mr. Fan, why is it negative 2.7?
Huh, now you ask me how come they equal negative?
Is it because it's going up instead of going down?
No. You have to go back with the negative inverting amplifier. What the gain for inverting amplifier? That's just a
Negative
formula.
R2 over R1.
Yeah,
Minus,
but it's negative. It's negative. Negative R2 over R1.
right, that's just a formula. I'm
Oh.
not making it up,
Okay.
okay?
Is it because it's using the negative side of the wave?
Okay, try to make sure you go to the op amp. You get inverting, non-inverting. When you see the circuitry, you have to tell me which one. This is just a formula. Input applied to the negative, that will be inverting. Input applied to positive, that means non-inverting. That is the first thing you must know. Then you have to know next one will be what is the gain. You don't have to prove it, but you have to memorize. For this gain in here will be minus RF over R1. For the non-inverting will be 1 plus RF over R1. That is the thing you must be memorized. I cannot help you out.
Hey, Mr. Pham, but I think what they're trying to understand is even though it's the formula, why is the negative in the formula? I understand what you're saying, but that the negative is in the formula, but why is it in there? We know that negative is inverting and positive is non-inverting. But what I think what they're trying to find out, why is the negative there?
Okay.
Because it's using the negative side of the sine wave?
Now, nothing to do with that sideways. Okay. Now, on that one here, this is the VL. Right?
Right.
Okay, VL will be measured from the output to the route. And also, VL can be measured from that to that one. That also route. Right?
Right.
So the current will be flowing this way. So you get positive here, that's negative here. Okay? So VL will be basically equal minus I right?
Right.
Okay. That is the VL. And now you get the gain. AV. VL. Divide VE. You get that?
Right.
VL will be equal minus I R2 divide V in. What V in equal?
I R1?
Time I. Right?
Right.
Yeah.
I time R1. That's the AV. And AV will be equal cancel I minus R2. That explains to the why they get minus.
Okay.
Okay? But I think you don't have to prove. Try to memorize the formula. Yeah, anything if you confusing, just bring it up. We try to make it clear for you guys. Now the cutoff frequency, still the same thing. 1
That's
over
159.
that is the same formula. 125 RC. What you get?
159.15.
15.9.
Kilohertz.
Okay. What the VO mic?
4.05.
Yeah, if you want to calculate, you can take the gain. Times the sine wave. Okay, the gain equal to minus, however, that will be applied for DC. For AC, that minus only telling you what input output will be opposite. Okay, so the right answer will be 4.05. Okay, not negative. Why? AC, you cannot put a negative. The negative side just telling you input output will be out of phase. And the last one, VRS 1.59K. That means they lower than 10K. Cut off 15.9. You divide by 10, you get 1.59K. And the output, they will be down minus 20 dB. So what you get? For mine, I get 0.286.
Mr. Pham, I'm sorry. How did we get this number again?
How? Can you repeat your question?
Yes. How did we solve number 5?
Number 5, that means the cutoff frequency changing for 1 decade. Okay, that means the output will be going to 0.1. You take the V out times 0.1.
Okay. So the V out that we have is 4.05 times 0.1. Is that what you mean?
Let's see. Number 4, what we get?
4.05.
No, sorry. 4.05 will be number 3.
Yeah, that's maximum.
Yeah, 2.86 for number 4.
Yes, yeah, 2.86. That's right.
That number okay, that's number 3.
Okay.
We are mic. That will be 4.05. Okay, number 4. That means at the cutoff frequency, they will be 2.86. and number 5 will be down to 0.1. That means 0.286.
So is it 0.1 times V out at critical frequency or
Right. That means at the cutoff.
at the cutoff times 0.1?
Right.
And not V max.
Okay. I get a wrong one. Will be time to remake. Okay?
So it should be 0.405.
Exactly.
All right, thank you.
Thank you. 0.405. Okay, that means they take 0.1 times 4.05. Okay?
And I'm sorry, Mr. Pham, like, so the 0.1 is constant, right, in this case? Or
0. Which number you talking about? Number 3, 4, 5.
so number 5, when we multiply the V out max multiplied by 0.1, 0.1. So where did we get the 0.1 from? Is it from the formula or?
Now, you understand when they down 20 dB, that means minus 20 dB. You cannot do anything with that minus 20 dB. You cannot do any calculation. So now you have to find out what number to get at minus 20 dB. That means you can take a 20 log 0.1. So that will be minus 20. So you have to multiply by 0.1. Same thing like minus 3 dB. When you say down minus 3 dB, you cannot do anything with a minus 3 dB. Then you have to say 20 log of 0.707 equal minus 3 dB. So you want to multiply, you have to multiply with 0.707.
Okay, thank you.
Okay, now my question is, if they going down to another 10 times FC, then you have to multiply by what number? That means they go to a 40 dB, minus 40.
0.001?
0.01, not 00.
Okay.
I think if you take the log of 20 log of 0.01, you get minus 40. Okay?
Okay. Thank
Okay,
you.
on this circuitry here, they just given you a two pole. I already telling you, when you get a 1R, 1C, that's a 1 pulse. Okay? That means the circuitry, you can get only 1R, only 1C. So that will be 1 pole. Okay? 1 pole will be going down 20 dB per decade. When you get 2C, 2R, that 2C, that 2R. So that's why they will be 2 pole. The thing is this, for this kind of the filter here, you don't care about the circuit. It's very, very hard to looking into the circuitry to tell what the name. They will be 2 pole, 3 pole, or more. No way. The thing is, basically, when you're working, and they just asking you apply input and measure what the output is supposed to be. And they telling you this will be a true pole, okay? Cannot memorize the circuitry. I just give it to you, the circuitry, in order to explain to you how you get the one pole, how you get the true pole, okay? And also, if you're looking into this circuitry here, can you tell me what the amplifier they yield to build?
Non-inverting amplifier?
What's the name?
Non-inverting amplifier?
Exactly. Non-inverting. What is the gain?
1 plus R2 over R1.
All right. Okay. Now the next one, band pass filter. Okay, first thing you're looking into the circuitry, what the name of the amplifier?
Non-inverting amplifier.
Right, non-inverting amplifier. What is the gain?
One plus R4 over R3.
1 plus R4 over R3. That's correct. Okay. So basically, you already learned that one. What is the name for this circuit?
High pass filter?
High pass filter. Okay. Normally, when you interview, they just give you that, asking you what is it. The answer will be, that will be output of the high pass filter. And the same for that guy here. What is it?
Low pass filter.
Okay, low pass filter. And now they combine high pass and a low pass to make the one they call a band pass. Okay, so that's why band pass they get a two cutoff frequency. One will be F low and one will be F high. Okay, any signal with a frequency higher than F low and less than F high are allowed to pass. Okay, any signal with higher frequency than F high will be rejected after F low. So the band pass will be from F low to F high. That's what they call a band width or pass band.
And Mr.
Now
Pam,
you
can I ask a question?
understand. Yeah.
I understand what you just said. Do the high pass and low pass, they have a bandwidth also, right?
Yeah, bandwidth for the high pass and the low pass, they only so right here. Bandwidth for the high pass here. This is the bandwidth for the low pass here.
Right. Okay. Yeah. All right. Thank you.
Yeah. So basically, this is
I have a question. How can you find out the bandwidth of a high pass? Which formula are we going to use?
band pass for high pass will be from FC. Go to whatever.
Okay, cutoff frequency to FL. Okay, I got it. Thank you.
Okay, now band pass filter response. output. Path frequency higher than F1, FL, or less than F high. That's what they're telling you. They get a bandwidth here. Okay, so they get a two cutoff, one FL, F low. Okay, this is the one. This is another one. Okay, and basically they will be going down for minus 20 dB per decade. Same thing like the other one. Okay, so any frequency higher than F high, they will be in the stop band. Any frequency less than F low, they will be stop band right here. Okay, pass band will be going from FL to F high.
And the bandwidth is in between, which is F high minus FL is BW.
Right, bandwidth.
Right.
Any question on this thing? Filter is not hard to do.
I have a question, Mr. Pham, here. So for the low pass and high pass, as far as connecting them to the circuit, does it matter if which one is to be in the input or the output?
Okay, you're going to make a band pass with a high pass, low pass, right?
Yes.
So you get a high pass first. Output high pass will be connected to the input of low pass.
Output high pass, input low pass. Okay.
Okay.
Okay. Thank you.
Inverting band pass filter. Okay. That they just give it to you. The circuitry. I have nothing to talking about this thing. Okay. Last one. Band stop filter or notch filter. So basically, this is easy to understand. They just opposite to the band pass. Okay, that means any frequency higher than F high will be pass, and any frequency less than F low to be pass. However, the frequency between F low and F high will be rejected. Okay. Okay, so basically on that one here, they just introduce to you a different filter. Okay. One filter section, two filter section. One filter section means one pole. Two will be two pole. Three will be three pole. And four will be four. Okay. And the bad will be four. The thing is, this is the bad one. Why they will be the bad one? The thing is, they will be narrow. Okay. The bandwidth here will be small. That's what they want. Why they don't want one filter section?
Too much noise.
Yeah, the thing is, the channel, that really high open, wide open. So easy to get the noise. Okay. Also in here, they just telling you different type filter from different engineer. First thing is you get Chapter-G, elliptical, Butterworth or best sale. So only thing they show up here, which one you think is the good one for the filter. Okay, you can see the ripple. Ripple in the band, that means you get a noise in the band.
The best sell.
Yeah, the good one will be first thing is they try to close into the ideal. That means they close to in here. Okay. However, they have to be less noise. So the first one elliptical, not good, right? The thing is they get too much noise. Okay. And the next thing is butterwood. Butterwood will be okay. The thing is, on the mid-range, they have a no noise. Okay. However, they still not a good one. Which one is a good one?
The Butterworth make you have a bigger bandwidth. And the best cell has a better.
Best cell will be better than Butterworth. They don't have any ripple, any noise in the pattern here. However,
excuse me.
Yeah.
Is Besso considered high frequency?
No, who cares high frequency or low?
Well, it's faster, isn't it?
Yeah, with high frequency for sure they will be faster. However, on this display they just show you which filter you think good. So the filter is good. They're not supposed to get the ripple in the pass band. And also they try to close to the ideal as much as they can. So on this here, you don't care about that. Why here and electrical they get a big noise. Only Butterworth and the best cell. But Butterworth and the best cell the same. They not get any ripple in the pass band. However, best cell get a better cutoff. Okay.
Because you want like a smaller bandwidth, is that correct?
Right.
Mr. Fan.
Yeah.
Other than filter, what component is the primary factor to keep a best cell signal as clean as possible?
No, that's the same thing. That means you have to looking into the best cell circuitry compared to the Butterworth circuitry. Then
Isn't it the fill time of a capacitor that determines that ripple effect?
no, they have to be different for somehow. I mean, you can get the Butterworth low pass filter, and also you can get the best cell, the circuitry, and you can compare to see what the difference.
Thank you.
One question, Mr. Pham. But here you're talking about active filters, so that mean it's necessary to use, for instance, an active component like an operation amplifier to build that filter?
Exactly. You can learn filter the same thing in the AC circuit.
Okay, got it. One more question. Given there is difference in the performance among these different filters, there is a difference also in the price to build a vessel in comparison to lower quality of these filters.
I'm not quite following, John.
In short, build a vessel filter that is the performance is superior to the other ones is more expensive?
No, I have no idea.
Okay, thank you.
You can take a two circuitry for Butterworth and a best cell to find out. Okay, so that's just a summary for you guys, everything. Okay. Let's see. This is the page you have to go through. Bandpass filter and all calculation here. Okay, they get a bandwidth. Okay, bandwidth and also equal F C2 minus C1. Okay, and you can using F0. What the name for F0 here?
Center frequency.
Yeah, you can say center frequency. FC1 set a cutoff lower cutoff, FC2 higher cutoff. Okay, that's very good. And also they get the Q. Q means quality of the filter. They will be F0 divided to bandwidth. Okay. Okay, let's see. This one just the not filter, nothing. Okay. So basically, remember, we only get 4 different types of the filter. Low pass, high pass, band pass, band stop filter. What I expect you to memorize, when they given you the output, you're able to tell what is it here, for example. Okay, they can tell you, asking you what is it here. Then you have to say that is the output of the band pass filter. Okay, if they want the bandwidth, then the bandwidth will be equal to FC2 minus FC1. Okay, if they want to calculate the quality Q, that means how good the filter should be, equal to F0 divided by the bandwidth. Okay. Any question? Anything? Okay, if it's not, make sure you download the Jfet for lecture today and tomorrow. Okay? You know, you have to go into the handout, download the Jfet of the phone 2020. So we'll be going to that.
Is the filter still in the handout?
Yeah, still. That means you download active filter, and also you have to download the Jfet. You must get that thing, okay?
And that's under digital handouts or what?
No, electronic lecture.
Okay. All right, I see it. Okay.
You get that?
Yeah.
That is one of the major in electronic we have been covered. Jfet will be the last one. We still get something else to do, like comparator, okay, like differentiator, integrator, okay, but that's not a major.
So, Mr. Pham, the main difference is the bipolar junction transistor is current control and the Jfet is voltage control.
Yeah, we'll see.
Okay.
Okay, now Jfet, it's a junction field effect transistor. It's a type of FET that operates with a reverse bias on a PN junction to control the current, okay? Depending on the structure, they can be either N channel or P channel. Now you see on that thing here, okay? They show you that is N channel, okay? N channel, that means that the P side, and in here, they will be N side, okay? And the first one to go here is the drain, and this will be the gate, and this will be the source, okay? For N channel. And the P channel, and you can see they will be P inside, okay, and N on the other. And they given to you the symbol here. That will be N channel, and that will be P channel. What's the difference?
The arrow pointing out on the P channel.
You can see right here, arrow.
It's either arrow in or arrow out.
Arrow in, N channel. Arrow out, P channel. And also they get 3 terminals: drain, gate, and the source. Okay. Only thing is make sure you understand when you see in the symbol, you know what is Jfet. However, they will be N channel or P channel. Get that?
Yes, sir.
What?
Yes, sir.
Now, 2 main type of FET. Jfet is the junction field effect transistor. MOSFET, that we call a metal oxide semiconductor field effect transistor. In the MOSFET, you can get a D MOSFET or the E MOSFET. D MOSFET means depletion MOSFET, and E will be enhancement. Okay, similarity. They can be using as an amplifier, a switching device, and an impedance matching circuit. That's the application for the Jfet. Different.
I have a question.
Yeah.
Is the similarity between what? A transistor and a Jfet? With whom it is compared?
You mean the simulation of what?
No, you said similarities. Similarities with what? Which other electronics components? Is it a transistor or what?
Transistor. That is a transistor.
I think, Mr. Pham, what the thing is one transistor is bipolar junction, which is emitter base collector, and the other one is a FET, which is drain source gate, and one is current control, and the other one is voltage control.
Exactly.
Okay, thank you.
We already get the bipolar. Okay? They can get NPN and PNP. In the Jfet, they say they get the N channel, a P channel. Okay? On the bipolar, you get the base collector emitter. On the Jfet, you get the drain, gate, and the source. That is the same thing. Okay? Now they're talking about difference between Jfet and the bipolar. FET are voltage controller device. Why bipolar is a current controller device? That's a very important. You must be memorized. They will be asking you. FET also have a higher input impedance, but bipolar have a higher gain. You want more gain, you're using bipolar. Okay? But you want to deal with the impedance, that the FET will be the good one. FET are less sensitive to temperature variation and more easily integrated on the IC. That means easy to build. Okay? FET are less sensitive to temperature variation. Okay? And easy to build. And FET also generate more static sensitive than the bipolar.
Hey, Mr. Pham, top of that handout there, you got MOSFET. The MOSFET, you can't be handling that with your hands. You got to have a special tool, right?
Right, we're talking about later. Okay.
Okay. All right.
Right now, we're talking about FET. They will be very sensitive. Okay.
I have a question.
Yeah.
So the last point of the differences is FET are also generally more static sensitive. What does that mean, static sensitive?
That means you cannot handling by hand.
Static electricity, basically.
Right. Your body get a more electric. That will be cooked the IC.
Inside the factory, you got to wear a special suit, right?
Right. Whenever you get a job, that is the first thing they training for you. How to handle the IC. Okay. Bipolar, okay, you can hold the NP, no big deal. But the FET have to be careful. Same thing like the bipolar. Jfet, before they can using, like the amplifier, they have to get the DC buyer. That means you get a big DC to make Jfet working first. Okay. VDD. You can see VDD right here. On the bipolar will be VCC. You need that power supply. Okay. And also you get another power supply. VGG. Okay, negative. Okay. VDD provide a drain to the source voltage and supply current from the drain to the source. VGG set the reverse bias voltage between the gate and the source. The Jfet is always operate with the gate source PN junction in a reverse bias. Okay. On the bipolar, they in forward bias. Now try to see this picture here to see what the difference. If you're looking on the first one here, okay, on this one, when they measure at the gate, you can see VGS will be more negative, okay, and current on the ID, we can see here, that is the current ID, okay. And now, if you see on this one here, VGS going low negative, and now ID will be more, okay. That only tell you this thing. This is what they call a channel, okay. More electron that are inside, more electron moving, you get more current. So if I'm looking on this one compared to this one, I see this will be more current, okay? So that's why they're using the meter to monitor. You get very high negative voltage. That means the current will be lower. And if you get less than negative, current will be more. That means the channel here, they wider, okay? That's how the current will be flowing through the current ID. And also that will be given to you, okay? The IC for the Jfet, okay? Let's see, what else? Now, see this one. You can see on that one here, when they draw the power with the arrow here, that means they can vary the voltage. So the negative voltage going down, keep going, okay? And that current will be increase. So the channel will be bigger. Okay, more electron will be moving from the drain to the source. Okay, now we see that thing. This is a Jfet. They connect to the route here. Okay, gate connect to the route. Okay, and you get a VDD. They changing the VDD. That means you changing the current ID. Okay, and on this one here, at the 0 here, at the beginning 0, okay, and the current ID. This stands for ID. Okay, ID going up. That means they change the VDD to make the current here go up. Okay, they keep going up to the point B right here. And now they not up anymore. Okay, in this case, they will be routed at the gate. That means they say VGS equals 0. Okay, so when they go up to this point right here, then they get the VGS now equals 0. And the voltage VDS right here equals VP. What is VP? VP they call a ping off voltage. What is the ping off voltage? Ping off voltage, that means at that voltage, the current will be constant, no more changing. Okay? And that's what they call a IDSS right here. So now, what is the IDSS? What is it?
Pinch off voltage.
That means the maximum current. However, that maximum current only happens with VGS equal 0. Okay? That's what they call IDSS. So now you can see if they changing VD, okay, the first one less than VD less than VP, less here. This time they call a ohmic region. What that mean, ohmic region?
The Jfet operates like a resistor.
Exactly. That means when the VD is less than VP, then the Jfet working like resistor. Okay? However, when the VDS higher than VP, ping off voltage, and now the current will be constant, and that equals IDSS. And that only happens with the VGS equals 0. Okay? And if they increase the VDS up to that point here, they will be break down. Okay? So basically, Jfet will be working like if the VDS less than VP, they can working like resistor. However, higher than VP and less than a maximum, VDS maximum in here. VDS max. Okay, they will be working like a current source. And that current will be equal IDSS. And after that, they get the breakdown. We don't deal with that. That will be cooked as Jfet. Okay? So basically, Jfet, they can using at a current source, constant current. and that will be ID at it. Or they can be using at the resistor. Like exactly in the bipolar, they can working like be saturation, or they can be working at the amplifier. Okay. Any question on that one? Oh, you don't know how to act.
Yes.
Okay, now this thing. The maximum drain current out of the Jfet occur when the gate source voltage is zero, VGS. Okay, maximum drain current. Okay, out of the Jfet occur when gate source voltage is zero. That's only telling you VGS equals zero. Okay, second thing, the drain current is almost constant in the region between VP and VDS max. What is VP?
Pinch off voltage.
Right, that means you must be memorized. Pinch off voltage. Okay, if the drain voltage is too large, Jfet should be breakdown. Jfet act like current source when it is operating along the almost horizontal path of the drain curve between VP and the maximum of VDS, like we just explained to you. Okay, from VP to V maximum, VDS maximum, they working like a current source, and the current will be equal IDSS.
Mr. Pham, a question.
Yeah.
Which two voltage? I know it's the pinch-off voltage and another voltage. They're equal in magnitude, but one has a different sign.
That will be, let's see. We'll be talking about that, okay, quickly.
In other words, a pinch-off voltage and this voltage that I can't think of, they have the same magnitude, but a different sign, like a minus sign.
Yeah, but VGS off. Okay?
Okay.
Get later, VGS off. They will be the same value with the VP.
Okay.
But they will be opposite. Okay?
Okay, thank you.
Yeah. Between ping up and the breakdown, they first act like current source with the value of IDSS. Remember, you must be reading this over and over. I combine too many different textbooks to summarize what really you need to memorize only. Okay? The minimum voltage VP equal a ping up voltage. Okay? IDSS stands for the current from the drain to the source with the shorted gate, a frosted gate, VGS equals zero. That's what I will be asking you all the time. What is IDSS? Okay? IDSS, that means
Drain the source with the gate shorted.
With the shorted gate, that means the gate will be short to route. Or mixed region. The almost vertical part of the drain curve equal on mixed region. That equivalent to the saturation region in the bipolar transistor. Cutoff voltage. The value of VGS that make ID approximately 0 is the cutoff voltage VGS off. Okay, so now we have to get one more. What is the VGS off? That means at that voltage, the ID current is 0. Okay? Comparison of pin off and cut off. VP is the value of VDS at which the drain current becomes constant and always measure at VGS equal 0. VGS off and VP are always equal in magnitude but opposite in size. Okay? VGS off equal minus and VP equal positive. Now, data set usually will give it to you VGS off or VP, but not both. If you know VP, you know VGS off. Okay? Or you know VGS off, then you know VP. Normally, on the data sheet, they given you IDSS. They given you VGS off or VP. Now, only see that one here. VGS control ID. Okay, if you look in here, you can see that is VGS. Okay? On the bipolar, that will be IB. So that's why bipolar will be a current controller. Now on the Jfet, you change the VGS, you change the current ID. Okay? For example, you get a point in here. What are VGS equal?
-2.
-2 volt. If you want the ID, you go to the left here. That will be ID. So basically VGS control the ID. So that's why Jfet is a voltage controller device. Okay? And now when you go up to this point right here, you going down, you can get VP. VP equal 5 volt. That means at that 5 volt, the current now they will be equal IDSS. That's a constant right here. Okay? And make sure you have to understand VGS equal 0. Okay, so the question is what is the IDSS? Okay, the answer will be IDSS is the maximum current. Okay, at VGS equal 0. Or they can say VGS is shorted. Okay, so any question on this picture here?
Is any component greater than 5 volts? Are there other components?
No. That means at the 5 volt, then the current ID will be equal IDSS. They start less than 5 volt. They will be in the ohmic region. Okay. Let's see. On this thing here, they say Jfet cutoff voltage. If you're looking on the picture here, you can see the channel. No more, right? This electron on this side cannot go to the other side. The thing is, P side is too big, okay? So that will be telling you what the current ID.
0.
It'll show you 0 amp. So when the current ID equals 0 amp and the VGS now be a VGS off, no more electron moving. So that's why no more current, okay? So what they said right here, at the cutoff, ID equal 0. And the VGS now will be equal VGS off. Any question? Just normally the picture now, you guys looking in a display will be bigger, right? Bigger like in the past. The display on the screen.
Yes, correct.
The thing is, I try to set it up the maximum display, okay? So that's why they make it bigger. The thing is, last time I see, Kuba told me what using the iPad to teach your guy. So that's why I'm not using the desktop. Okay. Hopefully that can help your guy to easy understand it. Now, the basic operation of the P channel. So now you can see what the difference. P channel and the arrow will be coming out. However, VDD now will be negative. And the VGG now will be positive. That's only the difference. Okay? They will be working the same. However, you can see the power supply will be different. Okay. Yeah. Question. Okay, now, example. For Jfet circuit cell, they given the UVZ of minus 4 volt and IDSS equal 12 milliamp. They want to know the minimum value of VDD required to put the device in the constant current area of operation. Can you do it? Now, like we already telling you, this is ID. that is VDS. And you already saw this one to draw this way. Okay. What voltage here?
VP.
Perfect. VP. What is the current here?
IDSS.
Right. Very good.
VGS at 0.
IDSS. And the VGS will be equal to 0. Right?
Yes.
And this will be the breakdown right here. We don't care. This is a constant right here. That's what they're talking about, constant current. That means in this area. So now they don't give it to you VDD. They're asking VDD. So you can say you can get D right here, F right here, get right here. Okay. So you can see VDD I can tell you VDD. That means the voltage drop across RD and DS. Okay. So VDD, they will be equal I D time R D, and you adding. That means the voltage drop here, adding the voltage here. V dx. Okay. Now VRD. Can you calculate the VRD?
I have 6.72. If we're using the value of IDSS as ID.
Yeah. The thing is, they want the current here to be how many? 12, right?
Yes.
So you get a 12 milliamp, you adding to time the 0.560. That means you can get the VRD, okay? 12 times 0.56. And then you have to get another one, okay? VDS. What the VDS equal? That means VDS will be equal, let's see, minimum value, okay, of the VDS to make it to be constant. That means VDS have to be equal VP. That means right here. Okay, minimum. What is the VP?
Pinch off.
That means they will be equal to the VGS up, but they will be, okay,
Positive.
positive 4 volt. Okay, now you calculate to tell me what is the VDD equal. First thing you need to calculate the ID times RD.
So is it 10.72 volts?
Perfect. Answer will be 10.7 volt. Okay. You calculate the VRD and you adding to the minimum. Okay. Required to put a device into the constant. You can see when you read it right here. Minimum value of VDD. Minimum to put it into the constant. That must be VP. You understand now? Or still? Okay, let's see. Next. Jfet transfer characteristic curve for N channel. Okay, so basically this stands for ID. This stands for VGF. Okay, now this point here, what ID equal?
0.
0. Okay, ID equal 0 and VGS will be VGS off. Okay, and another point right here. What VGS?
VGS is 0.
VGS 0. So that's what they call a IDSS. Okay, they say right here, ID equal 0. Then VGS equal VGS off. Or ID equal IDSS. It means VGS have to be equal 0. So that is the transfer between VGS, okay, and ID. Now, on that one, they display both. One for VGS 0, -1, -2, -3. And the other one, they will be display the curve, okay, for the ID and VGS. So this curve here will be calculated by this formula here. This is a formula to calculate the ID at any point. Any point here, Q point. Okay, any point. You want to calculate, you're using ID equal IDSS times 1 minus VGS divided to VGS of square. Okay, that's only the formula to using calculate the ID. Okay, and in here, for example, they given you VGS equal -2 volts. Also, they can telling you what the current ID equal will be 4.32. And if you going down, you can get VGS equal -2 volts. Okay. So we try to get to this example. We quit and continue tomorrow. Now, partial data sheet of a QN5459 Jfet indicate that typical IDSS equal 9 milliamp VGS of equal minus 8 volts. Using this value, determine the drain current ID. First thing for VGS equal 0, VGS equal 1, and VGS equal minus 4. Calculate that, you get the right answer, then we can quit. Okay, so again, I given you the formula to calculate ID.
The first one is 9 volts. Or I'm sorry, 9 milliamps.
VGS equal 0. Okay, you get on this one, right?
Yes, sir. I got 9.
Perfect. The thing is, ID equal ID F equal 9. You know why?
I think so.
But the thing do you know why they ID equal 9 milliamp?
Because of the formula, because you're using IDSS times 1 minus VGS.
Yeah, I understand what you say. ID, right? Equal IDSS, right? 1 minus VGS divide VGS off.
Yes, sir. Perfect.
Correct. However, we don't need that one for the number A. Why?
ID is max at IDSS when VGS is zero.
Because BGS is 0. BGS is 0.
On the number A, we don't need the formula.
Right.
VGS
EGS is 0, so IDSS will be 9.
ID equal IDSS.
IDSS.
Okay, calculate number 2. Then you must be using the formula.
7.875 milliamps.
It's not quite same mine. Well, get the answer.
I got 6.89.
But get the right answer.
50-50.
On that one, ID equal 6.89.
Yeah.
Okay, make sure everyone try to do it, okay? You want to be a technician, that's a very, very neat to understand it.
Wait. IDSS is 9.
And we get a last one.
1 minus -1
4.5
divided by -8. What am I doing wrong there? Oh.
What they want?
Squared. Oh.
I
So
got
9 times. Son of a bitch, I forgot the squared. 9 parentheses.
I got a negative 2.241.
1 minus -4 divided by -8.
You're using for number C. ID equal 2.25, right?
Times 9?
Yes.
Perfect. Need the time to read it again, okay? So tomorrow will be more and a little look like it will be a little harder. Anything confusing, not quite follow it, just let me know. We
Hey,
can,
Mr. Pham, on this one right here, the VGS off in the formula, would that be 0?
what do you mean VGS off? In here, they say,
In the formula, where it's 1 minus VGS over VGS off, is the denominator VGS off? I'm asking you, is it 0?
no, which one? You're asking about number A, B, C.
Number C, where you use the formula.
A, VGS off equal minus 8 volt.
It's up in the example.
Oh, yeah. I missed that. I'm sorry. That's why.
That means minus 4 divided to minus 8.
So because minus is a plus, and VGS is 1, so the reciprocal of 8.
Yeah, that means you have to apply into the formula ID.
Minus 1, yeah, times IDSS.
IDSS times 1.
Yeah, okay, yeah, I got it. Thank you.
Okay. Okay, any question?
Are we going to talk about what or how these things fail, what it looks like when it fails later?
What failed?
The Fed or the
You're talking about the textual,
transistor.
right?
What was that?
You get a question about what? Is it a D-lab or what?
Maybe. We had the other examples of what happens when the resistor fails or
what the
other components fail.
I think he means, are we going to learn about troubleshooting the Jfet?
Yeah.
Anywhere, anything. Have to go learn about how to troubleshoot it.
Yeah, eventually.
So that's why I try to give you measure you must know before you're able to troubleshoot it. You don't know how they work, then you cannot troubleshoot it.
Do you have a procedure point to point with the DM in order to determine?
That means this time we can do a good job. The thing is, next week, almost done everything on the lecture. Then the rest up to the end of the January, we have to deal with the circuitry. It's not working. What can you do?
Okay.
Hey, Mr. Pham, I got a question. So at the top of this example, it says VGS off is equal to minus 8 volts. And I know you didn't ask for it. So that means the pinch off voltage is plus 8, correct?
Yeah, VP.
Okay, yeah, so VP is plus 8.
Right.
Okay, thank you.
VGS off. Okay, make sure you guys read it. Tomorrow I asking you, okay? And you have to answer me. Like I asking you what the IDSS, how to get the calculate the ID. IDSS times 1 minus VGS over VGS off.
50-50.
Okay?
All right, thank you, Mr. Pham.
Yeah,
Yes,
good,
sir.
good night.
Good night.
Thank you.
Welcome.
Awesome.
Thank you.
You're welcome. Bye.